Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it later on. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are going to be taking questions from the audience. So at any time during today's presentation, you have a question, please don't wait, don't hesitate. Just use your GoToWebinar control panel and get your questions in. And we should have a few minutes before the end of today's webinar to go through the questions. And finally, also at the end of today's webinar, we are going to be doing a drawing for 3 $50 Amazon gift cards. So stick around. Hopefully you'll be one of the names drawn. We'll be making that drawing at the end of today's webinar, as I said, and we'll let you know then. Okay, with that, we'll go ahead and kick off today's webinar, which is Look Before You Leap, Migrating On-Premises Hadoop to AWS. Jason, I know you are roaring to go, so I'm going to go ahead and turn it right over to you and put myself on mute.
All right, thanks, Charlene. Hello, everyone. Good morning, good afternoon, wherever you happen to be. I would like to, first of all, welcome you to our webinar, Look Before You Leap, Migrating On-Premises Hadoop to AWS, which is sponsored by Unravel Data and AWS. So really quickly wanted to introduce myself. I'm Jason Beck. I'm a Senior Director of Product Marketing at Unravel Data. And we've had a slight change in our panelists at the last minute, and we're joined today by Javier Ramirez, who's also a Senior Developer Advocate at Amazon Web Services. So just to run through the agenda for today, we'll cover a few topics in turn. First, we'll cover the top reasons customers choose AWS for their cloud migration journey. And then we'll cover the advantages of planning out your Hadoop migration to AWS, and I'll cover that part. And finally, we'll show you a demo of the Unravel migration assessment capabilities that will ensure risk-free migration of your Hadoop environment. So we'll start with AWS. We'll go over the top reasons customers choose AWS for their cloud migration journey. And I will hand it over to Javier Ramirez from AWS. Javier?
Yep, thank you, Jason. So yeah, hello, everybody. Thank you for joining the webinar. And yeah, I'm going to be telling you why customers choose to migrate from on-premises clusters to Amazon EMR. And the main thing, the number one thing you might know about Amazon is that we really help you automate infrastructure. So of course, many customers are looking into moving to Amazon EMR because then they can focus on getting most of the data and not really on having to manage infrastructure. But that's not really the only reason. There are actually many other reasons why customers want to move their workloads to EMR. And one of the things you get when you are using your on-premises cluster is the storage that you have on your cluster is very, very, very much tied to your. Yeah, just for a second. Oh, yes, sorry about that, because I couldn't see when you are using your cluster on premises, is the storage is very, very tight together to your cluster. In a traditional Hadoop cluster, you are going to have a single cluster with several machines. Of course, you are going to have several master nodes. You are going to have several worker nodes, and those nodes are storing the data locally on HDFS. So basically, if you want to keep adding storage, you are going to need to keep adding nodes. And that's challenging in many cases. Imagine one of the workers, for example, is going down and you need to replace it. At that point, you are going to have HDFS replicating data quite a bit, and cluster is going to be a bit degraded in performance. But also, you are going to find that when you are sharing a cluster with different parts of the company, different departments, in many cases, you're going to have different requirements for the computing itself, for the hardware. Some departments might want to use machines with more memory. Some departments might want to use a different type of hard drive. Maybe you are running your cluster with a particular version of Hadoop or Spark, for example, and then there is a new version coming and you want to use some API which is only available in the new version, but since you are using the cluster shared with other people, you cannot really upgrade unless you are super sure that the other jobs are not going to be affected. So in general, one of the things we see when we are sharing a cluster in Hadoop is that you have to compromise on the lower common denomination of the jobs that are running in the cluster. So in the end, you don't really have exactly the configuration you would like to have, but the configuration which is best for most people that are using that cluster. And another thing that you are going to find on premises is that if you're using HDFS in a traditional Hadoop cluster, as you know, the data needs to be replicated to be sure we have both performance and reliability. And in traditional Hadoop, you have to replicate 3 times. If you are using Hadoop 3 and you are using cluster encoding for a few things, you might not want to replicate 3 times, maybe 1 time and a half, but still you are looking at some overhead for replication, which means you need to spend extra money on storage when you are using Hadoop. Well, as I'll tell you later, if you're moving to cloud, we have one way in which you can save with that. The last thing I want to tell you about when you are running a shared cluster is that when you have, a single resource and you have many different jobs competing to use the resource, at some point you are going to have many different people, many different jobs trying to use your cluster. And at that point, the cluster is going to be underperforming because jobs are going to be in the queue. You need to be waiting until there's a slot available, and no one is going to be happy at that point. On the other hand, maybe at night or in the weekends or at some points, no one is using the cluster and is sitting idle there, and you are paying for resources that you really don't need. So when you have a shared cluster, which is mostly static, as you have on premises, you cannot really adjust on demand the computing capacity to really what you would like to have at every moment. And that's another reason why customers are moving to more flexible cloud resources. So other than that, yeah. So on the same idea, and I already mentioned this a little bit, but if you have different type of workloads, as you know, in a Hadoop cluster, you might be running batch processes with Hadoop, you might be running SQL queries with Hive, you might be running a streaming with a Spark, and those are going to be needing different type of resources. And in a uniform cluster, you cannot really optimize for one particular workload. You need to optimize for all of them, which means it's never going to be really optimized for what you need in a particular point in time. And in the same, with the same idea, we get to the next slide, in which basically, if you decide to separate different clusters, it's like, you know what, we really need to optimize for this particular version of a Spark. You might want to decide and create a different cluster, but then you have 2 problems. One, you need to replicate data across clusters. You're going to be spending money, you're going to be spending time, you're going to be getting data which is really not fresh across different clusters. And then you're going to be creating data silos. It's going to be only natural that after one point, some data is living only on one of the clusters. So you cannot really get the insights from all the data in your company. And again, that's not ideal because data, if you have access to all the data, you can get very interesting insights when you can cross everything together. And the last point I want to make about the tutorials, because I want to start telling you really about the solutions, not only why people are not happy with the clusters, is that, as you probably know, in a Hadoop cluster, you're going to have very different types of data processing tools. You're going to have things like Spark or Presto or Hive or TensorFlow, different tools. And each of those tools need to be in a particular version to play well with each other. And it's going to be the case that at some points, if you want to upgrade a particular part of the software, it might be not compatible with other parts. So what you end up having is a cluster that you don't really want to change in case something is going to break, because it's actually very difficult to keep up to date with your cluster unless you are using some kind of a specific distribution. And that's another reason why it might be a good idea to move to something like Amazon EMR. So in summary, if you are talking about the challenges you are going to be finding when you are using your on-premises cluster, is you are going to be using the same setup for the hardware. So you're paying exactly the same, either if you are using the hardware or not. Storage and computing are very tightly coupled. So you don't get flexibility to choose different configurations depending on what you need. And you are not able to dynamically add capacity if you have a peak on the processing power and you need to do something right now. Your cluster is going to be always on. Even if you're using the cluster for doing just some processing in the mornings, you are still going to have all your cluster all the time working, which again is not the best use of your resources. And if you want to have different users deploying different parts of the cluster, you probably cannot allow self-service for those users. So in general, you're not going to be able to be very productive. You're not going to be able to deploy as quick as you will need if you are using your traditional, if I might say, your legacy cluster. So now, what is Amazon EMR? How we are helping you overcome these problems? Well, Amazon EMR is just open source Hadoop, exactly the same Hadoop you know already, exactly the same Spark you know already, exactly the same Presto you know already, just managed by us. So when you choose to use Amazon EMR, we are going to give you not only Hadoop and Spark, you can actually choose out of 25 different components, things like MXNet or TensorFlow for machine learning, things like Jupyter, things like Ganglia, things like Apache Flink. So you can choose out of 23 different applications that when you choose to start a cluster are going to be configured to play well with each other. Apart from using the applications that you already know in the open source ecosystem, when you move to AWS, of course, our cluster integrates very well with the rest of our ecosystem. For example, you can replace, and I'll tell you a bit more about this later, but you can replace your existing HDFS by Amazon S3, which is our distributed storage, or you can use DynamoDB, which is something similar, writes and fast reads. You might want to choose Kinesis, which is like message queue and analytics framework for real time, similar to Spark. You might want to choose Redshift, which is a data warehouse. The good thing about EMR, it's very well integrated with the rest of the ecosystem. So if you already have your cluster, you can migrate your cluster to EMR almost with no changes, and then you can start using little by little the other services that AWS offers you. So you can have a mix of your Hadoop cluster plus my fully managed services by Amazon. In terms of security, we offer a lot of different things. If you are already familiar with Kerberos and that's the way you like it, you can keep using Kerberos. But if you prefer to have some flexibility, you prefer to have Amazon-based authentication with IAM, you can also choose to do it like that. Of course, you can encrypt your data. We have the key management service that allows you to manage your encryption keys. You can connect to your installations, to your data center with Amazon VPC, so you can create your network and you don't have to worry about anything else. And you can go actually to our website and you can see we meet a lot of compliance requirements. So no matter in which industry you are, you can actually move and use Hadoop. And well, of course, the last point here is like scalability and resizing, but that's come here actually to this slide. The single best thing I like about EMR is like, I don't know what your experience creating a cluster on premises, but last time I created a cluster on premises, it actually took me weeks of work. With EMR, creating a cluster takes literally 3 minutes. You choose which kind of instances, how many machines you're going to be using as the basis of a cluster. And once you choose that, you also choose which applications you want to run on top. And then in about 3 minutes, we are going to be creating all the instances. We are going to create the internal network you need to connect the instances. We are going to apply the configuration that you choose from your Hadoop. We are going to install the applications that you are asking us to install. By default, we apply our configuration, but of course, if you want, you can override that configuration, and we can install like absolutely anything else. And after that, your cluster is up and running. So we are going from weeks to create a cluster to just minutes. And once the cluster is created, it's up and running, you can start submitting jobs using APIs, and you have, of course, monitoring, it's embedded there. If a machine goes down, you don't have to worry. The machine is going to be working. If you enable auto scaling, the cluster is going to automatically add and remove instances, worker instances at any point where the metrics are not going as they were. So you really don't need to worry about managing the hardware. We take care of that part. But I told you earlier that it's not only about having Hadoop, and actually it's not about having storage locally on your cluster. So the first thing you see here, when we're talking about EMR appears as a computing layer on the right-hand side, but actually on top of EMR, you can choose to have as many applications as you want. By default, we give you 25 to choose from, but of course you can install any other things from the ecosystem. The most important part of this slide is what you can see, the arrow going from HDFS to Amazon S3. Instead of using, you might want to choose Amazon S3, which is our distributed storage. There are a number of reasons for using that. The first one is, if you are using S3, you are going to be detaching storage from your cluster. And once you have a storage detached from your cluster, you can do interesting things. Like, for example, you can stop the cluster if you are not using it. Then you can restart the cluster again when you need to process something. The cluster is going to be up and running in a couple of minutes. And since the data was stored on S3, you didn't lose anything. So that's already super interesting in case you want to just have an ephemeral cluster that you can stop, and you are not losing the data. And that's going to help you save money and optimize on your resources. And the connection with S3 is done by a connector. This is installed automatically, which is fully compatible with HDFS. So you don't really need to change anything on your applications because HDFS is automatically supported. And we have the same thing for the catalog. If you are using the Hive catalog for metadata, you can connect to an instance on AWS, or you can just use something called the Glue catalog that stores metadata. So you can store data and metadata outside of the cluster, and then you can stop and start at any other point in time. And as you can see on the next slide, it's not only about stopping a particular cluster and then starting again. Something you can do is you can share data and metadata across multiple clusters. So you can have a cluster that maybe is running all the time because you are doing some things over there. Maybe you are presenting a dashboard and you have a small number of machines running some dashboards there. But then maybe you want to start a different cluster, which is started only for running an ETL job overnight, and it takes only, I don't know, 1 or 2 hours. You can start the cluster pointing to exactly the same S3, and that cluster may have a totally different configuration. Maybe one cluster is running a Spark 2.3, another one is running a Spark 2.4, another one is not even running a Spark, it's using HBase. In another one, you have, I don't know, machines with the worker machines have a higher memory. In the other one, you have very small memory because you are doing, I don't know, some processing that you don't need the capacity for that. The beauty of this is that different teams can create their own clusters. Different teams can choose to, exactly what they want. It's going to be very easy for you to actually attribute the cost, of each cluster to whoever is starting it, but they can all share the same data. So you get a lot of flexibility that you wouldn't get otherwise if you are running on premises on a shared resource. So no more competing for the same resources, no more having to compromise to the lowest level denominator. And when I'm talking about compute flexibility, and this will be my last slide, and with this I'm getting back control to Jason, you can actually choose from different type of virtual servers, what we call instances, when you create a cluster. We have general purpose machines, like might be the N4 or N5 family, which are like, generic processors. They don't have anything too special. If you have some kind of job that needs to have like very high computing capacity, you can choose from the C4 or C5 families, which are much more performant. They give you more bandwidth. They give you higher processing power, for the comparable price. If your problem is like you need to have some, I don't know, very high memory, we are talking about 1 terabyte, 2 terabytes, something like that of memory, then you can go to the Air 4 or the X1 families that give you exactly that. Or maybe your trend is you need to have a lot of local storage because you are running something that needs to be super fast with local storage. Then you can think of the i3 or D2 families. So basically, we offer you a lot of flexibility and totally hands-off management of the cluster. That's what I have for now, and I'm going to be handing this over to Jason. Thank you.
Awesome. Well, thank you, Javier. Thank you for that great overview of migrating your Hadoop environment to Amazon Web Services. So as Javier talked about, some of the reasons that customers are migrating to cloud data services like Amazon EMR are really around scalability and the flexibility that you would have to spin up different engines depending on your business requirements. And what I'd like to do at this point is really discuss how Unravel can help organizations in your journey to the cloud. So we'll get to the tools and techniques in a minute, but what I wanted to do is really start by reiterating what Unravel does in the big data ecosystem. So Unravel is a fully extensible data operations platform, which allows you to monitor and manage and troubleshoot your modern data platform across the entire stack. So that includes technologies that Javier just talked about, like Spark, Kafka, Hive, all of the open source Hadoop vendors like Cloudera and Hortonworks, as well as the cloud native services from cloud vendors like Amazon Web Services. So we cover Amazon EMR, as well as a variety of other services from other cloud vendors. As I mentioned, we help you manage and monitor and optimize your modern data platform, and we do this in 3 ways. Right? So first of all, we help you uncover the metrics and the operational metadata that's collected through our adaptive data collection technology using Unravel to really pull all of the metrics and the telemetry from the various disparate modern data platforms out there. So we automatically help you collect that information using lightweight sensor technology. And then we seek to understand that technology by aggregating that information into our common data model and correlating that information to specific context, whether that be an application or a job or a specific cluster you'd like to tune. We have years of IP and innovation in our correlation engine that allows us to really pinpoint the issue very quickly without having to sift through thousands of pages of logs and creating your own tools for that correlation. So in the process of doing so, what we do is we provide really the recommendation engine to allow you to pinpoint what configuration parameters need to be tuned or what step in your code is actually causing that error. So we get to the heart of the matter very quickly and allow you to resolve that issue without too much effort. And finally, we're able to proactively automate those issues or automate those in a way that allows you to apply that remediation in a set it and forget it type of manner. So we proactively allow you to trigger certain actions in our auto actions so that if you have issues that you're running into over and over again, we ensure that you don't repeat the same mistake more than once. So it shouldn't come as a surprise to anyone that on-premises data pipelines are being re-architected for the cloud. In fact, we have a recent Forrester study that concluded that the cloud markets are actually growing 7.5 times faster than on-premises. And this is not just due to scalability and cost benefits, as we mentioned earlier, but it's really the pace of innovation that enables new use cases, such as predictive maintenance and faster cancer research that's driving that growth to the cloud. Now, Unravel has helped many customers in their journey to the cloud, and it's really due to the fact that we see the operations and the migrations stages of your cloud journey kind of interdependent on each other. They're very complementary to the journey to your cloud. So we have a very strong heritage in on-premises Hadoop systems like Hadoop and Spark and Kafka, the NoSQL databases. We have many experts in the company that are very good at tuning those systems. And what we've done is apply that same knowledge to apply to the migration step in helping you assess exactly what you need to migrate, help you discover what's in your cluster, and help you map out what needs to happen in your journey to the instances that correspond to the cloud. So you can see that the journey to the cloud includes not only just lifting and shifting, but also re-architecture as well as you apply your Hadoop environment to the cloud. And what we've noticed in our customer base is that a lot of customers start very carefully in lifting and shifting just the applications that perhaps they can't re-architect. They just want to see an experiment. Does it actually work in the cloud? Is it the cost that I'm expecting? And then they start to refactor some of those applications to cloud native platforms like Amazon Redshift. So we help in that journey because we're able to discover what's in their cluster and help them assess exactly what's going to cost in the cloud environment. So understanding that the costs and risks of migration are at the forefront of any Hadoop migration, here are some of the questions that we get commonly at Unravel in that migration journey. So what we noticed is that the customers don't want to just migrate. They actually want to use this opportunity to refactor and optimize their environment. So they ask questions like, well, is a lift and shift the right approach, right? And you may want to do that just to get your workload into the cloud. But am I going to get the cost that I'm looking for, the cost advantages that I'm looking for? And which apps should I migrate first? Oftentimes we see that the Hadoop cluster in question is kind of a black box, and they're not sure what's in there. And our tool actually allows you to help discover what's in that cluster so that you can make the appropriate decisions. As I mentioned, our customers seek to optimize while migrating. So a lot of questions about storage come into play where they start to question, well, I don't need all of my storage migrated. Maybe that wouldn't be cost effective. Perhaps I can leave some in on-premises or cheaper layers of storage and migrate the hot or warm data as I need to. So we help you make that determination in a data-driven way. So in response to these questions, as I mentioned, Unravel has built a set of migration assessment capabilities into our tool. First of all, we provide cluster discovery, right? So as I mentioned that oftentimes the on-premises environments are sort of black box, kind of a mishmash of different open source technologies and different versions. Well, we can tell you what all of the components are utilizing in terms of resources for that cluster. So in terms of memory and storage, we'll tell you exactly what the usage happens to be and the seasonality of different rates of usage across time periods, as well as good candidates for cloud usage. So perhaps some of your workloads are bursty in nature, and that may be a good candidate for the cloud. And we provide a dashboard to actually let you see that in real time so you can make that determination. We also provide instance mapping in terms of allowing you to match your target or your source to the target in terms of a goal-oriented approach. So your business requirements may dictate that you do a straight lift and shift and not disturb any code. but what are the financial ramifications of that in terms of cloud usage? We give you a very precise report that tells you down to the penny how much that's going to cost. And then you can kind of adjust that as you need to based on different optimization factors, based on the usage of your on-premises cluster. And it's a feature that we call cost optimized usage, where we're able to optimize it for the right EC2 instances that you have in mind. And finally, in any migration, it's natural to really compare the before and after picture, right? So our customers really value the screenshot that you see here, where we're comparing the on-premises cluster performance to the cloud cluster performance. And you can see here in the screenshot, it might be a little hard to see, but this application happens to be right out of the gate, it's a lift and shift, and happens to be 17 times slower on the cloud. But that's because of any optimizations haven't been applied using our tool. So right away, you're going to get some recommendations that you could apply to your Unravel optimized instance and get that cluster performing in line with the SLA expectations. So oftentimes, customers get sticker shock, and we've seen this over and over again by really improperly planning their Hadoop migration. So I can't tell you how many times I've seen customers say, well, let's just lift and shift and pray for the best. That's just a proof of concept. Well, that may be, but oftentimes they have a certain expectation that even if they decide to dive headfirst into the migration, they sometimes have a false expectation that their cloud cost will be 3/4 or half the cost of their on-premises cost after an implementation phase. And that's not really the reality. What we've seen in reality, and Gartner supports this as well in their research, is that the cloud costs, the total costs actually go up because certain costs are still retained from on-premises. And this may be due to business requirements. It could be due to regulatory requirements, maybe architectural requirements that you didn't foresee. And then our customers go through a series of cost optimization exercises to get to the true cost. So the value of Unravel is that we allow you to cut to the chase. We get you to that cost optimized stage without a whole lot of experimentation in the process. Okay. So here's another view of the same thing. It's really the cost savings provided by Unravel's data operations platform. You can see that without Unravel, some of the earlier stages are the same. You're doing some detailed technical scoping, but without Unravel, you really are left to gather all of the data and the evidence through discrete logs and perhaps creating your own tools for that correlation and that aggregation of information to put into context. So you're really left without very good productive tools to allow you to make the determination of what should I migrate in the first place and in what order, which draws out the migration and adds to risk at the end of the day. So with Unravel, what we allow you to do is provide that automated aggregation, the summary report that allows you to put everything in context, give you a sequential step of what to migrate and at what time, all provided by evidence that we gathered for your on-premises cluster. So that's really the value of Unravel. So just to reiterate once again the value of Unravel to the Hadoop migration, we find it kind of difficult at the end of the day to separate the operations from the migrations because we see it as a continuous journey of not only looking at your source and your discovery of your on-premises cluster, but also after migrating, you're continually looking to optimize your cluster and perhaps do this in a series of steps versus in a one shot, right? So as I mentioned, we have a rich heritage in on-premises Hadoop and big data performance tuning. And we apply that to our migration features in the Unravel tool. And we use that intelligence to land you in the end state, which is the performance management for your cloud platforms. But we see this as a continuous journey where you're constantly tuning. But the advantage here is that you have the same interface, whether you're on premises or in the cloud, and you have the migration capabilities to really support the evidence of what you should migrate and at what time. So just to show you some of these features in action, so you get a sense of exactly what you're looking at in terms of migration capabilities, we'll be showing a demo by our Senior Director of Product Management, Abba Jain. So I'm going to go ahead and hand it off to Abba.
Unravel Data is an application performance management platform that helps customers understand and improve the performance of their modern data applications on any platform. Unravel also has a rich feature set that can help you accelerate migration of your modern data applications to the cloud. This includes providing the recommended cloud topology based on your current on-prem workloads and how much it would cost. Migrating to the cloud sounds easy, right? Well, not quite. Wholesale migration without proper planning is akin to moving a 7-bedroom house last minute. It can be done, but it will be expensive, inefficient, and take twice as long. This is exactly what the research from Gartner says. Unravel aims to make this process simpler and cost efficient. The main challenges that make this process of migration difficult are the lack of adequate understanding of the current environment, figuring out how to prioritize applications to move to the cloud, coming up with the optimal cloud topology design, getting an estimate of how much running these workloads in the cloud would cost, and last but not the least, ensuring that the applications when moved to the cloud will perform at least as well as they did on-prem. Let's see how Unravel can help. To start with, Unravel gives you unprecedented visibility into what's going on in your environment. For example, this cluster is clearly underutilized, and this makes it a good case for the cloud because in the cloud, you only need to pay for what you use. Had there been overutilization, it still would have been a good case for the cloud because you could make use of the agility that the cloud provides. Unravel gives you the details of usage in terms of, for example, what application types are running in the environment, which are all the users utilizing this platform, what are the various departments that are using this platform, and so on. A heat map like this of your workloads in the cluster gives you the necessary information about designing the auto-scaling strategy for your cluster in the cloud. In terms of data, Unravel labels your data as hot, cold, or warm based on business policies that you can configure yourself. This easily translates to a tiered storage strategy in the cloud. Unravel also helps you decide which workloads are good to move to the cloud. For example, ones that need varying amounts of resources over time. This can make use of the agility the cloud provides. Next, based on the granular data collected from the cluster and applications, we give you a cloud topology simulation to figure out the best cloud topology and cost before you move. You pick the desired target, could be IaaS or PaaS, the region where you'd like your clusters to come up, and you run a report like this. You can choose between the lift and shift or cost reduction strategies, and you can get a suitable cloud topology that including the estimate of how much it would cost you. This was if you move the entire cluster at once. In case you were to move a slice of applications to the cloud, Unravel gives you a simulation for that too. You can choose the slice of applications to move, the target where you would like your applications to come up in the cloud, and then run the report. You get a single cluster recommendation with price performance trade-off. So for example, here's the topology and the cost of the cluster if you wanted the applications to meet their resource requirements 100% of the time. However, if you're okay with some SLA degradation in order to achieve cost savings, we show you options for that as well. We also tell you how much you stand to save if you were to configure auto-scaling in the cluster in the cloud. You can also choose to migrate your selected slice of applications to multiple clusters, each one running different type of applications. Now, rarely do big data applications perform perfectly right out of the gate. After the migration, Unravel can help reconcile application performance by comparing the performance on-prem and how the applications are doing when in the cloud. For example, you can see that our application in the cloud is performing 17 times slower than when it was running on premises. But using Unravel's insights and recommendations, you can improve the performance of the application in the cloud and declare a successful migration. To conclude, we saw how Unravel addresses various challenges of moving big data environments to the cloud. It helps you helps you develop a deep understanding of your current environment and provides insights and recommendations for your cloud deployments, helps prioritize applications to move to the cloud, provides you with an optimal cloud topology design given your specific workloads, including an opportunity to exercise price performance trade-off. You get realistic estimates of the costs involved. Unravel also helps you ensure that your applications perform better or at least at par with the performance that they had on premises. In summary, Unravel can help you mitigate risk, provide clarity, and help you plan the migration of your modern data environment to the cloud so that it gets done faster and in a more cost-efficient way. Thank you.
Okay, can everybody see my screen at this point? Just want to make sure.
Jason, you're showing the preview screen.
Preview screen, okay, give me 1 second. Okay, you see the slide?
I'm still seeing the preview screen. The slide preview screen. There we go.
Okay,
Yeah, that's good.
Perfect.
Okay, apologize for that. So thank you, Abba. So hopefully you understood some of the benefits of using Unravel in the migration of your Hadoop environment to the cloud. So what we're going to do at this point is provide you with some offers. So as Abba mentioned, some of the reasons to migrate to the cloud environments like AWS really are enhanced and made more productive by the Unravel experience. And to help you properly assess your migration, what we wanted to do is just offer the audience and anybody else out there who's looking to migrate your Hadoop environment to the cloud with a cloud migration assessment offer from Unravel. So this is a 15-day cloud migration assessment service provided by Unravel. So we'll spend maybe a day or two just understanding the scope of your project and understanding in detail which clusters and which application you'd like to manage or migrate. And then we will go through a comprehensive exercise of installing Unravel into your on-premises environment. And we'll gather all of the telemetry and operational metadata that's required to hydrate our tool to provide you those insights and recommendations that I mentioned earlier. So that'll take about a week. And then we'll come back and we'll go through a very fine-grained summary of what it takes to migrate your Hadoop environment to AWS. And we'll provide detailed recommendations on what that would take in terms of technology and services. So that's something that we like to offer to our customers. Please reach out to us. We'll provide an email address at the end of the session, and we'll be happy to come out and provide a service for you. Now, by taking advantage of this service, what we see is that this really gives you the best possible transition with the insights and recommendations and guidance that we're able to provide to make the best determination before you actually migrate. Right? So I mentioned, and as the title of the webinar suggests, you really need to look at what you're getting into before you leap into the migration process, because it could be pretty drawn out. And our aim and our objective is to ensure that you make the best decision possible with all the information you have at your disposal. So we like to provide that and just have that as an offering out there. And we also wanted to mention that we have a $2,000 cloud credit offer for just trying out the Unravel for Amazon EMR product on the AWS Marketplace. So this is a 14-day trial. It's free and clear. No purchase required to get these credits. It's really meant to offset the cloud expense that you would incur just for trying out Unravel, and actually includes more credits than you would require just to try our product. So please go ahead and look for Unravel in the AWS Marketplace, and you should be able to see that. And if you are interested in the credits, then just simply shoot us an email, and that's in the listing itself. Just shoot us an email and we'll get that process started for you. So in terms of presentation content, that's all we had. So we'll go ahead and address some questions. Okay, so this first question is for Javier. So Javier, I see a question. If I have a significant amount of data that I want to move to S3 storage, what is the best way to do this?
Well, first, we need to make sure it's actually a significant amount of data, because if you have already Hadoop cluster and you want to migrate to S3, as you will do with any other cluster. But let's imagine you have a really large amount of data. We are talking about hundreds of gigabytes or maybe even petabytes of data, and you need to move to AWS. In that case, doing it over the network is not going to be practicable, because it's going to be just too much. So we help you with that with a couple of options. If we are talking about an amount which is on the terabytes of data, then in that case, you can actually use a service we call Snowball, which is basically a hardened device. It's an array of hard drives that we can deliver via courier to your data center, and then you copy your data locally from your cluster to that device, and you send it back to us. And of course, during the process, there is like full traceability of the device. We have like electronic tags and so on. So you get the device back to us, and we connect it directly to our data centers, and we put the data back into our data centers. If you have like a really large amount of data, we are talking about several petabytes of data, because some of our customers are going to have that need. Imagine you are processing, I don't know, digital satellite imagery or video or something like that. In that case, we have the option of the Snowmobile, and the Snowmobile, it's basically a trailer. So the trailer is a full, like a super hard drive. If I'm not mistaken, the capacity of a single Snowmobile will be something like 700 petabytes of data, something like that. So you can actually transfer a huge amount of data on a single trailer. In that case, what we do is like we drive physically the truck to your location, to your data center. The truck comes with a 2 kilometers cable that you can plug to your network, and then you transfer the data locally to the trailer. The trailer drives back to our premises, and we unload the data locally to AWS. And the whole process, like if you have a fast enough network and you want to offload the whole trailer, it takes about 1 week. If you try to do that over the network, it will take years. So that's one option. And of course, when you request the snowmobile, you can actually request a security escort. So we are going to be having actually some physical security together with the trailer, because your data is super important. So we have different options to move in large amounts of data. But bottom line here is that it can be done. We have the means to actually move in your data, no matter how big it is. You can actually request several snowmobile at the same time, and we can deliver several in parallel to your location.
Great, thanks, Javier. So we have another question here. I think that's directed more towards us. Is it better to lift and shift, or to re-architect my entire Hadoop environment to the cloud? So we see various different things. I think a lot of customers, surprisingly, are opting to lift and shift first. I think that's really driven by the need to preserve the existing code that you have in your applications, and to really ratchet down the unpredictability of ancillary factors that may be present in your migration. So I see a lot of customers just simply lifting and shifting their existing, let's say, Impala cluster or their Spark cluster directly to IaaS, and then make a further determination to see what could be optimized, whether they need to just simply tune certain configuration parameters, or migrate certain workloads to a cloud-native platform like EMR. So the beauty of what we're telling you today is that Unravel has all of those capabilities to help you make that determination quickly. So if you do opt for a lift and shift, then we can tell you exactly what that's going to cost you down to the penny. And if you do opt for more of a cloud native or a PaaS discussion, then we can tell you what that's going to cost as well. So using Unravel in coordination with your migration process will definitely get you ahead of the game. So we have another question here that says, does Unravel charge separately for migration capabilities versus operational capabilities? And the answer is no. We do include the migration capabilities because, like I mentioned earlier in the session, we see these kind of go hand in hand. You'll constantly need to optimize and tune the performance and get to the root cause of individual cluster elements, but we see this complemented heavily by the migration functionality that we put into the product. So we don't see a one-shot migration of your cluster. That may be a little unwieldy at the end of the day if you have a large cluster. So we see this as kind of an iterative process of migrating a little at a time and adjusting performance using our tool, ideally, to get to the end state. So definitely that's an advantage there. Okay, I don't see any other questions.
All right, great. Well, what we can do is we can kind of put out a final call to any final questions. And while we're waiting for those to go in, we can go ahead, come in, we can do the Amazon gift card drawing. So if, why don't we go ahead and do the first drawing? The winner for the first gift card is Kevin D. I'm not going to say the last name, but for privacy reasons, but Kevin D, congratulations. And our next winner is Chris P, as in Paul. Congratulations, Chris. And our third winner is Victor G. Congratulations, Victor. We'll be getting in touch with you, all three of you, offline via email after today's webinar to get your gift card over to you. And let's see, it looks like doesn't look like we've gotten any more questions in. So Jason, I don't know if you have any final parting. Well, actually, maybe we did. Yes, a question did come in, Jason. I don't know if you want to go ahead and take care of it, or if you want me to ask it.
Yes. Would you mind just asking the question?
Sure. Sure. The question is, hi, can I assess my data warehouse workload having complex business rules using Unravel?
I believe the answer is yes, but I actually have our senior solutions engineer on the line, Unravel. Mick, would you mind helping us answer that?
Jason, that's correct. We actually have the ability to identify what components of your environment are part of that particular workload, and then you can assess those. You can also put those in the chargeback report and delineate this however you need to throughout the product.
Great.
Awesome.
Thanks,
All right. Great. Okay, so Jason, I don't know if you have any final words that you want to impart to our audience before I close things out?
Yeah, absolutely. So in addition to the offers that I mentioned, if you have any questions whatsoever, please email us at hello@unraveldata.com. And in addition to the $2,000 the AWS Marketplace offer, we do have a test drive offer that allows you to just experience the product itself without any installation whatsoever. It's a lightweight client that allows you to just kind of click through and see what your optimization and monitoring and management experience looks like for any of the full stack experiences that we covered. So I wanted to really thank everyone for joining us. I want to thank our co-presenters at AWS. And I'll hand it back over to you, Charlene.
All right, great. Well, before we close things out, I do want to remind the audience. Well, first of all, I want to thank the audience for the questions that came in. So thanks very much for that. But I do want to remind everybody that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll be able to do so. We will be sending out an email a little bit later on today that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. And while you're there, please take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Jason, Javier, everybody who was on today's webinar, thank you very much for your time. Really appreciate some really good information there.
Thank you.
Awesome. Thank you.
Bye.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.